this is a great show. It's my first time in Germany, first time I've ever been to the Embedded World Show, and it's huge. There's a lot of buzz around here about the new technologies that are available, and I'm really enjoying seeing all the different booths and all the new technology that's out there. Okay, so I had first of all become interested in the PSOC 4 from Cypress Semiconductor, and I had ordered a Pioneer kit to experiment with that technology. But then they announced this Smarter Life Design Challenge, and I decided that I would try and showcase the technology with a smart thermostat, which met that theme of a smarter life. And I could do that by just adding a bunch of low-cost modules that are available commercially to showcase that you can interface this chip to anything out there in a very easy and low-cost way. And I wanted to lay it out in a format where you could see what I was doing. So all the modules are shown here in a picture frame, making it more like a little piece of art to showcase the technology in graphic form. So it includes showing the wiring between all these modules. It's all directly connected as shown with these wires. There's no interfaces needed between all of these things. The PSOC Pioneer kit already has the interface built into it, so it's a very simple way to implement a complicated project like this. Some of the other things I wanted to do was to have a clock that was visible across the room. So this was part of a thermostat, is to be able to program the temperature at the time you want. But I wanted the clock to be able to be visible from across the room. So I made these large digits on the liquid crystal display, and you can see it's changing the time here. And I also wanted to get the time from a satellite, because the satellite GPS data includes a real-time and date information, and it never needs to be set. It's always very accurate. So if I could get the GPS module here to receive the satellite information, I could have the time always be correct. And that works very well in my house. Not so well in a steel building, but certainly in my two-story house it works great. Some of the other features in this thing: there's a Bluetooth module which allows me to control the device from a smartphone or a PC, and there's about 50 different commands to control the various functions on here. They'll be setting the clock schedule or the temperature schedule and so on. Some of the other modules, there's a servo motor here which is used to raise this window so that you can access the touchpad. There's a microphone just to show that we can monitor sounds and respond to them. So if you tap on the screen, for example, you might want to open the window. There's a light sensor here, which you're basically using to control the backlight brightness on these liquid crystal displays. There's a temperature sensor, of course, for the thermostat to be able to control the temperature in a house. The touchpad, of course, allows us to program the schedule for the temperature. It's got one of the things I wanted to do there was to make enough buttons that you didn't have to be running through a bunch of menus to set up the schedule for your house. So there's a different button for each day of the week, and a different button for each time slot in the day. There's 4 different time slots in a day, and there's a different button for each temperature that you might want to set. Then there's some power supply stuff. Over here there's a humidity sensor. This is the thermostat interface, so this controls the furnace or the air conditioner or the fan in your house to circulate the air. And I mentioned the GPS module, which is only actually interested in getting the clock information. There's no position requirement. And one of the things that I was sure that we could get just the clock information from was because that the clock information is coming from every satellite. When you're doing GPS position, you need to lock on to several satellites, 4 or 5 satellites. But for getting clock information, you just need one. And of course the Bluetooth is really interesting because you can now use the power of your cell phone and with a much better display and user interface to control this. So you're leveraging the technology that's in a cell phone to be able to control your thermostat. So that's basically the technology. Okay, I can run through some of the functionality. First of all, I'd like to mention that one of the things I did want to do was to build in some personality to the project, just to make it more interesting as a showcase. So, for example, I gave it a name. I called it the Henrietta Project. Henrietta is actually a German name that means ruler of the home. So it's appropriate for this, which is a home control thermostat type application. And I built in some expressions into the display here. So for example, I can show you that it has eyes that are used to indicate to the user when they can do things. For example, when I ask it to open the window, it will wink to indicate that it's accepted the command and to acknowledge the command. And so when, in fact, when you push on this screen, it will open the window. And what happens is that the display will wink at you and give you a chance to move your hand away to get it open. We can, I just pushed a button here to show that there are some sensor data that you can display more detail about what's going on. So it's showing you the light level, the temperature, the humidity, and the coordinates of this pad that when you push on it. It's also showing you more information about the time and date. So this is the real time and date, the full time and date down to the nearest second. And we can also bring up the schedule for the temperature. So this is showing you the schedule for Monday, and there's 4 different time zones and a temperature associated with each one. This thing can allow us to change those just by pushing on a particular day. So for example, if I push on Wednesday, it'll show Wednesday, and if I want to set a temperature in a time slot, I can put in 22 degrees, and it shows up here as 22 degrees. Well, I find this whole challenge and road test initiative by Element 14 to be extremely interesting. It's very motivating, and it certainly gets the technology out there. I'm sure that when this challenge was announced, it inspired many people, many designers to think about what they could do with this technology. And even if they didn't enter the contest, they still thought about what they could do with it, and they may not have been able to do it in the time frame that this contest was run, but they're still going to use it just because it was announced as a challenge. So I think it's a really good initiative, and I think it's very positive for all the designers out there. I have plans for a project which is vehicle instrumentation. I have another plan for a wearable instrumentation, and a third one which is another home automation project. I can't say too much more about them because they may end up as products and I don't want to give them away yet. But basically there's a lot of things you can do with this technology, and I'm certainly looking forward to working with Element 14 to help that happen.